All right, let's get into another chemistry question. This one says, draw a plot of pressure versus moles of gas for an ideal gas. Label the axes, including units. All right, well, let's draw some axes first. So there's our x and our y. We can just label them pressure in moles. Oftentimes we measure pressure in atmospheres. I'll just use that for our unit. And then moles is just measured in moles. And I think what this question is getting at is, what is the relationship between these two things? Well, that relates to the ideal gas law, which is PV equals nRT, where P is pressure, V is volume, N is moles, T is temperature, and R is a constant that sort of balances the whole equation out. So R is just a number and isn't a variable in this equation. But what we're dealing with here, I believe, is what they're asking is, how are they related? So basically, if two things are multiplied on either side of the equation, and they're on opposite sides of the equation, if one goes up, the other one has to go up to balance it out. If we think about volume and temperature, R is always going to stay the same. If we make pressure bigger, then N is going to have to get bigger. The number of moles is going to have to get bigger to compensate, to make the right side of the equation still be equal. Like, for example, if I add a 2 over here, what you do with one side of the equation, you have to do the other. So I would also have to double this side of the equation, and we could do that by doubling N. What we call this is a direct variation relationship, is what these two variables have. Pressure and volume, on the other hand, have an inverse relationship. If we double P to balance it out, if we wanted to use V to balance it out, we'd have to divide V by 2 to cancel out the 2 here, if that makes sense. So when pressure goes up, volume has to go down to compensate. Usually it would be the other way around. If you think about, if you make volume smaller, then pressure goes up, right? There's more pressure if you condense something. That's why you can pop a balloon by condensing it, right? Because you make so much pressure that the balloon explodes. And I think it also makes sense in context here that if you add more moles, the pressure will also go up. So as we add more of something inside of a container, if we add more gas, if we're pumping a balloon full of gas, the pressure will go up inside of that thing. And that relationship, if we're drawing a graph, would be relatively linear, and we would show it as pressure goes up, moles goes up in a linear relationship, and I think this is a perfectly reasonable graph to represent this situation.